can see we have several unusual pieces of input-output equipment here. We have a scope, a knob. These are unusual at the time, and push buttons, toggle switches. We have several other related devices. This made the TX2 a prime candidate for the Sketchpad developments back in 1961, and it remained a program in this machine, so it would become a coherent partner in graphics, so the man can communicate with the machine.
Now, how do you actually go about communicating with a computer in a graphical sense? Well,
we are using an oscilloscope here, which is much like a TV set, except it's being driven by the computer. In order to get the information into the computer, we have to draw somehow on this display, and we use the light pen. Well, in order to construct a meaningful engineering drawing, we have to have several graphical manipulations. Ivan Sutherland's programs can draw straight lines and circles.
Well, that's about what you do in the drafting equipment anyway, isn't it?
That's a very good start.
T-squared.
In order to do this, we can position this bright spot in the middle of the cross that you notice at a desired location. And we press the button to command the computer to draw a line. It will draw a line from this position, where I am now, to any subsequent position of my light pen. This is much like a rubber band stuck in two pins. One is nailed on the screen here, and the other is at my light pen. So I can position this anywhere I want. Now, I lost tracking there. I moved the pen too fast, and that told the computer to stop drawing the line. Well, if you notice, that bright dot will jump onto the line as I get close to it.
Well, the dot in the center of the cross, when you get close to the line, jumps over onto it.
Correct.
Why does it do that?
It's much like a gravity field. At the end point, it is even a higher gravity field to allow us to position the point exactly on the line, or in this case, exactly at the end point. This allows me to move my pen quite coarsely, be sloppy while I'm drawing, and get a precision drawing out at the same time. So now I'm going to draw a second line.
Yeah.
And even a third one. Now, in an ordinary pencil and paper drawing, all we have is this particular picture. But the computer understands the geometry of the drawing here. What do I mean? I mean that if I point at this particular point and tell the computer to move that point by another push-button command, it will move not only that point, but all three lines that are attached to it.
And the delay between it's doing what you want it to is because it's computing all these changes.
That's correct. Now, if I made a mistake, I could delete my mistake by pointing at the line in question, for instance, and pressing the appropriate button. It's gone. Now, I mentioned before we could draw circles also.
Right.
In order to do this, I must first indicate the center of my circle. Let's choose it to be here. And then I'll move out to an initial radius, let's say this point right here, and I press the second button to start drawing the circle. Here's our circle. Let me reduce the drawing slightly so our circle shows on the computer scope. And you see as I move the pen, it is ignoring the radial position. I've just gone off the scope screen here. The radial position of the pen and only looking at its angular position. So I can
be very sloppy as you like, in other words.
Right. In other words, the computer has supplied the compass here, much like as it supplied the straight edge for the straight line.
If you go backwards, you erase it.
And I can wind it up the other way. Now, if I tell the computer to put that point right at this circle, right in that point right there, the computer knows that those must be connected. It turns out that they're not this idea what I want to have in mind. Now, as I draw my part, let's say, on the scope, it reinforces what I have in mind. This is, in general, part of the design process. And as I apply design criteria, stresses, and so on, eventually I will know what the exact shape of this part is. I shouldn't be required to draw the exact shape at the beginning. I really don't know what it is. But let's say I've decided eventually in this model that I want these to be horizontal and vertical, a box. I can apply a new constraint, a horizontal constraint here, a vertical constraint here, and a horizontal here by pointing at the line and pressing a button. Well, no, nothing has happened yet because remember I still must tickle that toggle over there to command the computer to satisfy these constraints.
So you won't actually let those rubber bands relax then until you say so.
Right. And I'll do that and watch again. There we have a box.
Well, now, this idea of having constraints like this, being able to make lines meet or to make them horizontal or vertical, makes it quite a step ahead of something that's just a drafting machine that allows you to draw, doesn't it?
Exactly. In other words, you can get the topology down of the part, and at any subsequent position in your design, you can make it to behave exactly what you want. Straighten the drawing up. In other words, you don't have to draw exactly at the beginning like you have to do in drafting. This is, of course, just one aspect of the program.